Hey, what's up, Bloomfield? And welcome to part 2 of our quiz review. So here we go. All right, so on problem 15, we're looking at average rate of change. And remember, average rate of change is exactly the same thing as slope. And so when we think about slope, we think about, well, what's the change in y over the change in x, right? So I can think about it like that, change in y over change in x. Or we can say, what's y2 minus y1 over x2 minus x1. So that's slope, or the same exact thing as average rate of change, right? So average rate of change and slope mean the same thing. It's how much change over time. Well, here it says I have a function f of z equals 1 minus 3z squared. Well, in this case, z is like our x, right? That's the same thing as kind of x. And f of z, so that would be the same thing as y. So this is like saying y equals 1 minus 3x squared. Well, it says here, so that means the same exact concept. So I can plug values in to our equation and see what we get. So we're plugging in z minus 2, so that'd be our first x point. So our first x point says, well, what happens when z is negative 2? What is our y value? The next one would say, well, what is when z is equal to 0? What is our y value? Well, when z is equal to negative 2, I'm doing 1 minus 3 times, so 1 minus 3 times negative 2 squared. And so that could be 1 minus 3 times 4, or 1 minus 12, which would be negative 11. So that would be negative 11 here. When z is equal to 0, I'm doing 1 minus 3 times 0 squared, which would just be 1, right? So now I can actually plug in and find the average rate of change. All I'm doing is just taking, well, negative 11. All I'm doing is then just plug it in. So I'm taking negative 11 minus negative 2, and then 1 minus 0. So this would become negative 11 plus 2, right, over 1, which is just negative 9. So my average rate of change is negative 9 for part A. All right, for part B, we're doing kind of the same concept. Well, exactly the same concept. So I'm saying f of x is equal to 3x squared. And here, when x is equal to 2, right? So I'm looking for x when x is equal to 2, so that I know 2. I don't know what y is. And when x is equal to 2 plus h, I don't know what y is. So I have to actually plug those in and see what do we get. Well, when x is equal to 2, I get 3 times 2 squared. So that would be 3 times 4, which would be 12. So when x is equal to, that'd be 12. When x is equal to 2 plus h, I get 3. And then this would be 2 plus h squared. And so when I square that out, this would become then 4 plus 4h plus h squared. And so I'd get 12 plus 12h plus 3h squared. And so that would be my y would be there. So this would become 3h squared plus 12h plus 12. All right, so now I have my y2, y1, my x2, x1, and so I can plug into my slope formula, right? y2 minus y1 over x2 minus x1. And so I can take, well, that would be 3h squared plus 12h plus 12 minus 12 all over 2 plus h minus 2. And so what does this actually look like? That's the difference quotient, right? Well, the average rate of change in calculus, when we look at that, it's actually finding the average rate of change of a curve. And so you'll actually be doing those kind of things, but that's what this means. This is then 3h squared plus 12h, where the 12s would cancel out, all over h, which if I factor out the h, we can say that's h3h plus 12 divided by h, which the h's go away, and just gives me 3h plus 12. And so that is my average rate of change for that equation. All right, for this one I have g of x equals 2 over x plus 1. Once again, we want to find out what happens when x is 0, what is my y, and when x is h, what is my y. Well, when x is 0, so this would be just 2 over 0 plus 1, which would become 2. So when x is 0, y is 2. when x is h, I get 2 over h plus 1. So that would just become 2 over h plus 1. And so now I have to actually subtract that. Well, we're going to do 2 over h plus 1 minus 2, right? h2 minus h1 over x2 minus x1, so minus 0, which I don't really need to put the minus 0, right? Well, I know in this case, this looks like something we've done before. I have to get a common denominator. Well, my common denominator would have to be multiplied by h plus 1 over h plus 1. So then this would become 2 over h plus 1 minus 2 times h plus 1 over h plus 1 all over h, which then simplifies. So I can say this would be then 2 minus 2h minus 2 over h plus 1 divided by h. Okay, well, continuing on with that, well, the 2's are going to cancel, so 2 minus 2, so that gives me negative 2h over h plus 1 divided by, right, h over 1, which is the same thing as multiply, so I got that's negative 2h over h plus 1 times 1 over h. And since these are both multiply, I can get rid of those. So my answer here is negative 2 over h plus 1. And that is our average rate of change for that problem. All right, here, so if I want to go ahead and put this in standard form, we could do the complete the square technique. So there's two options we could do. We could complete the square to put it in standard form, or I could just do and find what is x by doing the axis of symmetry, right? And then find out what is the y as well. So these are the two different techniques that I could use to find the vertex or to put it in vertex form. Well, I'm going to do complete the square. All right, here we go. So completing the square, we know we have to be able to move this negative out. I can't have anything in front of that, right? So I'm going to move the negative out, make this then x squared plus 3x. Go ahead and move the 3 to the other side. So here's negative 3. We're trying to fill in our gaps, right? So I need to be able to fill this in with b over 2 squared. So this would be then 3 divided by 2 squared would become 9 over 4. And then adding that to the other side, so this would become then negative 9 over 4, because that's what we put in with the negative there, right? And then b over 2, so this factors down to negative. This becomes then x plus 3 over 2. All right, so then this would equal, now we want to be able to, in order to add these together, right, we need to put them into common denominator, so this would become, the negative 3 would become negative 12 over 4, and then minus 9 over 4, which I could put together. So my vertex form then x plus 3 halves, and this would equal negative 21 over 4, and I can move that over, so I get x plus 3 halves plus 21 over 4, and that's our vertex form. All right, so then I'd be able to easily be able to change this in, and we know our vertex then, the x-axis of our vertex would be negative 3 halves, and the y would be at 21 over 4. And just like transformations, what's inside switches and what's outside stays. And once I know the vertex, I can really just plot the vertex and see where we go from there. All right, so here the vertex was at negative 3 halves. So that's at negative 1.5, right? And it was at 21 and a 4. So it's just a little bit above 5. So our vertex point would be right here. And that's our axis of symmetry as well. We also know, based on looking at our problem, we know that the y-intercept was at 3. So here's our y-intercept at 3, and I can use that. I can go across here. Here's 1.5 to 3, over here to 3. So if I go across 1.5, here's a half. Here'd be 1. Here'd be 1.5. And we get the same point here at 3. So those points have to be symmetrical around that. And I can really use that to draw out my parabola. I know it has to look like that. And there we go. There's our nice parabola, and we're done. All right, here for problem 17, we're going to do the same process. Now this one should have had an x here, but let's move the 3 out front. We're going to make this then x squared. Dividing by the 12 by the 3 would make this negative 4x. And we're going to move the 13 over to the other side, so minus 13. go ahead and fill our gap with b over 2 squared. So this would be negative 4 divided by 2 is 2. 2 squared would be a positive 4. And 3 times 4 would make 12. All right, and so I get 3. This is going to be then x minus 2 squared, and that's going to equal a negative 1. Move the 1 over. And standard form then would be, vertex form, x minus 2 squared, then plus 1. We know our vertex then occurs at 2, 1 would be our vertex. And I can graph using that information. So all I really need is the vertex. We know that the y-intercept is at 13. And those two pieces of information, really, I can generate a pretty decent looking graph. All right, so graphing that, we know the vertex has to occur at 2, 1. So x is 2, y is 1. We know that the y-intercept is up here at 13. I know that, so here's my axis of symmetry down 2. So if I go across 2, so 2 over, so from 2 over to 0 has to be at 13. So if I go over to 4, it has to also be up at 13. And then really, if I wanted to get a clearer picture of what really happens, let's look and see what happens when x is 1. So if I put in 3 times 1 squared minus 12 times 1 plus 13, then this would be 3 minus 12 plus 13. And what would I get? So here, so I got 3 minus 12. So negative 12 and 13 makes 1. 1 plus 3 would give me 4. So when x is 1, y is at 4. And so I get the same point on the other side. And there is my nice looking parabola right there. And there we go. We're done with that one.